Hello everybody. I know this will be something new for everybody, I'm guessing, online learning, probably the first online class you've ever taken, not that it was supposed to be, but I do hope you've enjoyed your break and enjoy the time that you'll have to relax now. Well, hopefully everybody will be able to get used to what we'll be doing here over the coming weeks. Both you and me, I know it'll be a feeling out process. Please email me anytime you have any questions. What I'm going to do, and I know everybody, all your different professors will set it up a little differently. I'll send you out emails periodically, so just make sure you're checking, at least once a day, if not multiple, just for all of your classes purposes. What I would like to do is really try and keep this as traditional and as what we're used to for the first half of the semester as I can possibly do. So, just to kind of give you a little lead in, I'm going to run my notes pretty much the same way that I would have run them in class. So I would really recommend that you keep a notebook, even take notes right alongside as we do this. I'm going to work out example problems. Obviously you won't be able to ask me questions live, but I will do my best to try and keep them the same as what we've been doing in the past. So to get into the new section that I did start the Wednesday that was right before our spring break, I know about half of you missed class, so what I'm going to do first of all is one example of what we did on that Wednesday. Again, if you were there that last day before class, feel free, if you want to just, after I've written the problem down, try it on your own, fast forward it, or if you were real good with what we did that day, by all means just skip over until we get into the new examples. So again, first thing I'm going to do, one review example from what we did on Wednesday, the last day of class that we were together, and then we're going to finish off section 3.1 within this video, and again I'll post other ones for each section then. So what we did, graphing quadratic functions and models was what we began with. So the first thing, a quadratic, which we've talked about, it has a degree of 2, meaning it gets 2 solutions, 2 x-intercepts. A quadratic function opens upward or downward as a parabola. So I know that's a general graph that we've done in the past, but now what we're building towards is getting more specific and getting more, with the characteristics that we use to graph these. So again, the general graphing method that we have for these, and there are 2 different forms that we're going to see. One of them we saw the class right before break, and the second one will be what finishes off this section. Regardless of the form, and the 2 forms are general and standard. We saw general already. The general, just a quick 3 steps that we go through. First thing I always like to answer is, will the parabola open up or down? So will the parabola open up or down? That's a very easy question. It's something that we can answer right away just looking at a quadratic equation. This is all dependent on the sign of the leading coefficient. So the sign of the leading coefficient, which we label as the A coefficient. So this would be, if A is positive, the graph opens upward, and if A is negative, the graph opens downward. Okay, so again, very easy general characteristic to get a good sense of right at the beginning. The second thing that we do is find the vertex. Okay, and this looks different for either of the 2 forms that I mentioned, both general and standard. Okay, so the vertex being, you can kind of think the initial point, what I would have described in previous lessons as being the anchor point for this type of graph. So it's always going to be the first point that we start off with. Where does the parabola open upward or downward from, whether it's the maximum or minimum? And then the third step that we're going to follow for graphing these is to find intercepts. Okay, so again, an old concept that we've used already, and I'm going to go ahead and throw in with this to find intercepts or other points. So find intercepts or other points on the parabola, because it will be possible that we don't have any x-intercepts. We will always have one y-intercept. There's a good note. One y-intercept, we will expect 2 because of the degree of 2 that a quadratic equation has. But again, we will see cases where that doesn't happen. And if we we don't know, we would possibly need to find points in order to get a more accurate picture of what our graph looks like. So what we're going to start in with here as I mentioned, I'm going to start off with one example to review what we did the class before break. So again, if you remember, anybody that was in class that day, by all means, feel free to move forward through the video or try the example that I'm going to put up here on your own and see how you do with it. If not, anybody that did miss, or I know it has been a couple of weeks if you forgot, here's what we do anytime we are graphing an equation in what is called general form. Okay, so make this note off to the side. I like to describe it as this is the way that you generally see it. We've talked about factoring strategies, and the reason why I emphasize those moving forward that we're going to need in this chapter. These are the forms of equations that we factor, and we use those when we find x-intercepts. Okay, so general form, again, you're going to see both positives and negatives with different aspects of both that are easier compared to one form or the other. These intercepts are generally easier to find. But again, going through our checklist that I wrote on the board, step one, I look at the sign of the leading coefficient. In this case, so the a coefficient is understood to be 1, which is positive, therefore the graph will open up. Once we go to graph this, so again, I'm going to have my initial point, my vertex, and from both directions it will open upward. Step 2, we find the vertex. Find the vertex. Now, when we are graphing in general form, this is a real important formula to know here. Vertex, again, this is a point. I have to have an x-coordinate and a y-coordinate. And there's a small formula that allows us to find the x-coordinate of the vertex, which is this one here, negative b divided by 2 times a, b, and c being the coefficients of our form. Okay? So what I'm going to do then, so if it's negative b, what I identify is that my b coefficient is negative 8. So when I go to replace that in this formula, that's going to become a positive 8. It's always the opposite of whatever the b coefficient is. On the bottom, 2 times a, we've already used a, it's just 1. So 2 times 1 would go on the bottom. 8 divided by 2 times 1 then is 4. So there's the x-coordinate of our vertex. And again, think about what we're finding. We are finding a point. It's an ordered pair, which means I need to now use that value to find the y-coordinate. All I do then is I simply go back to my original equation, use that to find the y value, substitute in 4 wherever we see an x. So y is equal to, instead of x squared, it will be 4 squared minus 8 times 4 plus 7. Okay? 4 squared, just left to right here, is 16. Negative 8 times 4 is negative 32. And then 16 minus 32 plus 7 will be negative 9. Okay. So what I have found, there's our first point. 4, negative 9 is where this parabola is going to stem from. So what I'm going to do here, off to the right, just kind of build the graph of this. And what I always like to do is emphasize, go from general to specific. So again, I know 2 things right now. I know the vertex. I know that I can plot the point 4, negative 9. Okay? That's what I know. And if that's all I knew, I also know it opens upward, so at the very least I can get a good general idea. But now what we're going to do, we're going to make this a more accurate picture. So I'm going to clear this, but step 3, we're going to find any intercepts, and if necessary, other points if this one does not have intercepts. This one will, hopefully, if you can kind of visualize what this graph is going to do. Okay, so step 3, I'm going to find any intercepts that this graph has. Okay? Solved differently, whether we're trying to find y or x intercepts. So going back to our old ideas from last chapter, anytime I'm finding intercepts, it means I have two sets of work I have to do. On one side I'll find the x-intercepts, and one side I will find the y-intercepts. So I'm going to use my equation twice. The y-intercept, you'll notice, especially in general form, is always going to be the easier of the two to find. So the y-intercept, we'll start there. Remember, going back to old ideas, intercepts are found because of how they're defined. I know that to be a y-intercept, it must have an x-coordinate of 0. So that's how I start the process here. Now, this one I'm going to write out just for this particular example, but you can pretty well assume it's always going to be that number at the end when we're in general form, because 0 squared minus 8 times 0 plus 7, those are just going to drop out. There's our y-intercept. Always emphasize writing these as ordered pairs just for organizational purposes. There's another point we now know on our graph, and again, we'll make it more specific. The next part, we find the x-intercept. Okay? Now again, we're going to expect 2 always, and that's because of a good review. The degree of this equation is 2. That tells us how many x-intercepts do we expect. But the procedure is still the same from things that we've done in the past. So y equals 0 is now substituted in because x-intercepts have a y-coordinate of 0. All right, now this is where anytime we're finding x-intercepts, this is where we want to emphasize and think about any factoring strategies that we might need to use. So this one is just a simple 3-term factoring problem. There's no greatest common factor. You could always use quadratic formula if you wanted to. I would emphasize do it this way, it'll be much quicker if you can factor it. So now I think, what are my factors of 7 adding up to -8? Those would be -7 and -1. Finally, last thing we have to say are what are these intercepts then? What are our values? And those two numbers then, of course, the values that make each one of these factors equal to 0 would be +7 here and +1 here. And once again, that gives us 2 ordered pairs that we would be able to plot on our graph here. Okay, so now we'll go back to our graph board. This will pretty well finish up the picture that we have. Okay, so again, we've just found 3 more points. The first one we found was the y-intercept. That would be 7. The other 2 points that we found are 7, 0 and 1, 0. Okay. All right, so we now have a picture. Now, this is good enough, I would say. For as specific as I would want you to get with these, you know enough. You know points on either side of our vertex. That gives us a good idea of how this graph is going to open. Now, the other thing that you can always do to get other points, parabolas, if you graph them correctly, must be symmetrical about the vertex. So it has to look exactly on the left side as it does on the right side of the vertex, if you can kind of picture a vertical line being drawn here through the vertex. So with that, not that you have to do this, but just because of symmetry aspects, I must also know there's actually a point at, so if this intercept is 1 unit away from the y-intercept at 7, I know that from this x-intercept, 1 unit to the other side of that and up 7 would also be a point there. You'll see why when we graph this. And again, the reason I'm saying this is the point 8, 7. Symmetry allows me to get that point. So now we'll see how bad I can make my graph. Not the worst I've ever done, but there you have it. We have points on either side of the vertex. Again, there's the review of the method in graphing with general form. Okay. Next, to finish off this section, as I mentioned, so anybody who was in class the day before break, this will be new. We saw general form, now we see standard form. So how do we graph now when we have standard form as opposed to general form? First thing to note, well, what is standard form? All right, so this will look a little bit different. So standard form of a quadratic is A times the quantity x minus h, quantity squared, plus k. Okay. Now, the big advantage that standard form gives us compared to general is that our vertex is readily available to be read off at the moment. I don't need a formula to do it. So if you just think of any equation, there's always an x and a y in it. These three, so A, H, and K, will be filled in with values. Now the vertex, I can read it right now. It's actually these two coordinates right here. Whatever is grouped with x, that is the x coordinate of the vertex. That h value, the k value, is the y coordinate of the vertex. So again, no work involved. The only thing you do have to be careful with, and this actually relates back to our transformation ideas. When we see a minus h, it actually means it's a positive x coordinate for the vertex. So think back to our shifts again. When we thought about horizontal shifts, if it was a minus, that actually shifted it to the right, the positive direction. So that's why a negative value here will actually produce a positive x coordinate. So again, just one of those things you have to keep in mind. It's always the opposite sign of what you would expect. Going back to vertical translations, when we have a positive at the end, that shifts it up. Okay? And again, that will hold true here. So the y coordinate is the sign you would expect, x coordinate, opposite of what you would expect. The other characteristic that I'll list here with standard form is that the same rules for A, the leading coefficient, apply compared to general form. So if there's a positive in front of the whole equation, it will open up. If there's a negative value in front of the whole equation, that would force the parabola to open downward. Okay. So again, what we're going to do here, we'll go over one or two examples here of graphing in standard form. So graphing in standard form. Again, we'll see the positives and negatives to graphing this way. So the first one here, y is equal to negative 2 times the quantity x minus 1 squared plus 4. Okay. So again, the same three-step process here will still apply that we did with general form. We're going to determine general characteristics first. What direction will the parabola open? What is the vertex? Where does my parabola start from? And then what intercepts can we find that will be on this graph? So the first question to answer, A is a negative 2. So a negative value will mean that the parabola opens down. Step 2, here's the big advantage that standard form gives us. The vertex is very quick and easy to find. Okay, the vertex is very quick and easy. So going back to the previous board of notes there, remember there's the x coordinate, there's the y coordinate. So again, I just have to remember that the x minus 1, that causes me to have a positive 1 x coordinate, and then the number at the end is the y coordinate, positive or negative. So again, there we have it. We have, again, two characteristics we could start with here. Again, if I knew nothing else, I at least have a very good picture of what this is going to do. I know that I have my vertex starting at 1, 4. And from there, just kind of think about what this is going to do. It's going to open downward in both directions. So hopefully you can see we are going to have 2 x-intercepts, and we are going to have 1 y-intercept, which we will always have. So step 3, intercepts and other points. So first, we'll find the y-intercept here on the left. by substituting x as 0. Now, the temptation to avoid here, we can do this with general form, we cannot do this with standard form. I cannot assume that this plus 4 at the end is the y-intercept. It actually would be impossible to be that, because then if we go to our graph here, I already have a point at that value. I can't be moving out horizontally. So again, just something to keep in mind, not as easy to read intercepts off in standard form compared to general. So the process though all stays the same. To find the y-intercept, I'm just going to replace x with 0. And then evaluate from there. So 0 minus 1 is negative 1. Okay? Don't be tempted here. I do not do negative 2 times negative 1. We would have to square anything before multiplying. So we still have negative 2 times, this will become positive 1. Negative 2 times 1 is negative 2. Negative 2 plus 4 is 2. So once again, we now have one point that we will eventually plot. It's the y-intercept 0, 2. Moving on to the x-intercepts. So this will be a little differently because we're not going to factor. There'll be actually an old strategy involved with this, but it always starts the same way. I still substitute 0 for y. And now what we're going to do is just think of using any equation solving steps to isolate our x here. Okay? So what I'm going to do, I think I can move that plus 4 over by subtracting 4. Okay, to emphasize, distributing, foiling is not going to get us anywhere here. It's actually going to undo a lot of work we've already done. There's no need. Next, again, just think about what's holding x back. One of those things is this multiplication by negative 2. So what I can do is divide by negative 2 on both sides. Negative 4 divided by negative 2 is 2. You can see how we're getting simpler here. Again, think I now have x. It's paired with a negative 1, but right now it's being squared. So the inverse of squaring is to take a square root. Now, to keep in mind, remember, when we take a square root in an equation, I must remember plus and minus, and remember the reason for that. Degree of 2, I have to expect 2 intercepts, and that's what that plus and minus does for us. So again, square root of both sides to get rid of the square, and now all we have to do is add 1 to both sides. So my final answers, 1 plus or minus the square root of 2 are our x-intercepts. Now, that does nothing for us as far as graphical purposes go, so what I would recommend here, get approximations for x. So what I'm going to do is 1 plus the square root of 2, get a decimal, and 1 minus the square root of 2, and again, get another decimal. Those approximations as points, 1 plus the square root of 2 is approximately 2.4. Again, these are not exact, these are approximations. And then if I do 1 minus the square root of 2, that is approximately negative 0.4. So again, not exact answers because the square root of 2 is not an exact value, but now I do have 3 other points that I can approximate now on my graph and build this a little bit more specifically. So the first one, 0, 2, would go up 2. And then my x-intercepts that I'm going to approximate would be 2.40 and negative 0.40. Okay. And you can see if you graph it semi-accurately, it does still have that symmetrical aspect around the vertex. And of course, we knew this one would open downward. And as I've always said, I never expect perfection out of your graphs if I can't expect it out of my own. So that is specific enough. I know points on either side. That is graphing in standard form. So last thing I'm going to finish up with is one more example of graphing in standard form. So second one here, f of x is equal to 2 times quantity x minus 5 squared minus 3. What I would recommend you do at this point, if you felt good about the last example, pause this one, try it through on your own, pick it back up and see if your work matches up with mine at the end of it. So again, feel free, pause it right now, work one out on your own and see how yours matches up. As always, first thing we start with, what direction will this parabola open? It is a positive 2 coefficient out in front of our quantity. That means the graph will open up. Second thing, vertex. The vertex of our parabola here will be, again, it is a minus 5 in parentheses, which is going to cause our x coordinate to be positive 5. And then a minus 3 at the end gives us a negative 3 for our y coordinate. Okay. Next thing, intercepts. Intercepts in other points. So once again, same procedure. The y-intercept, I'm going to fill in x as 0. Okay? F of x and y, of course, synonymous, meaning the same thing as we've talked about in the past. So it doesn't matter which one I write. So I'm going to have y equals 2 times 0 minus 5 squared minus 3. Okay? Once again, just be careful, order of operations here. 0 minus 5 is negative 5. Negative 5 squared will be positive 25. 2 times 25 is 50. 50 minus 3 would be 47. So we have our first ordered pair that we would be able to plot there. And on the other side, the x-intercepts, we fill in y as 0. Or f of x, again, regardless, doesn't matter which one we say. We have 0 equals 2 times the quantity x minus 5 squared minus 3. Once again, you're going to see very similar solving steps to the last one that we just did. I want to isolate this, which means I'm going to have a total of 4 operations. I'm going to add 3 in order, divide by 2, take the square root of both sides, and finally add 5 to everything. So to go through those steps in that order, divide by 2 on both sides. I'm just going to leave it as 3/2 for now. And once again, we'll get approximations at the end. The square root of both sides eliminates the square. Okay, again, I'm just going to leave this as plus or minus radical 3/2 for now, and for graphing purposes, we'll get an approximation for that later. Add 5 to everything. We would get 5 plus or minus the square root of 3/2 equal to x. And again, 2 approximations, 5 plus 3/2 is approximately 6.2. 5 minus the square root of 3/2 is approximately 3.8. Again, giving us 2 more ordered pairs that we would be able to plot here. So to finish this off, to see what our graph would look like, our initial point is 5, negative 3, our vertex, so down 5 and right 3, right 5 and down 3. Okay. Next, we had a y-intercept of 0.47, which my graph does not go to. So the x-intercepts, to finish those off, 6.20 would be approximately here, and then 3.80 would be approximately here. So we can see I have my vertex. We knew it would open upward, and sure enough it will. And not that my graph is anywhere close to accurate, but if we were to extend it enough, we would hit that y-intercept of 47 that we plotted also. So again, there's all the notes out of the first section. Again, think of the things we've done, which are characteristics of quadratic equations, determining the direction, what are the vertices, the vertex of a graph, what are the intercepts of a graph. So all ideas, the key things that will be important throughout this section to remember are any or all parts of that. What I'll be sending out, I will be emailing out a suggested homework assignment from the textbook that I recommend you try. Email me with questions for that. And again, all that information I will send out. Please be checking your email. Again, we'll get used to this and hopefully make it as smooth and seamless a transition as possible.